Alright, this is a worksheet for Advanced Algebra 1, concentrating on area problems. And so a rectangle is 3 times as long as it is wide. And I think it's important to draw pictures for these problems. So right now, it's 3 times as long as it is wide. So if the width is x, then its length would be 3x. And then the length and the width are both decreased by 2. So in other words, we're going to take this width and we're going to decrease it by 2. We're going to take this length and also decrease it by 2. And the area, if I do that, the area is decreased by 36 square centimeters. And there's a number of ways I could set up this problem. I could take the area of the whole great big rectangle and subtract the area of the little rectangle, the new rectangle, and that difference would be 36, because that's how much the area is decreased. I could take the area of the big rectangle and subtract 36, and it would equal the area of the smaller rectangle. And that's my preference. If I do that, I don't get into a situation where I have to distribute the negative. And if I distribute the negative incorrectly, then I'm going to get the problem wrong. So I'm going to take the area of a rectangle is just length times width. So x times 3x minus 36 equals the quantity 3x minus 2 times the quantity x minus 2. And I multiply this out, 3x squared minus 36 equals 3x squared minus 6x minus 2x is going to be minus 8x, and then plus 4. Notice what happens to the 3x squareds. I can subtract and they drop out. And so I have negative 36 equals negative 8x plus 4. Subtract 4 from both sides. I get negative 40 equals negative 8x, and x is 5. And we want to find the original dimensions. So the original dimensions are going to be 5 centimeters by 3 times 5, 15 centimeters. And the answer, that's the way I'll look for your answer to be written. The dimensions with the units. Next problem, a rectangle is twice as long as it is wide. So again, this would be x then, and this would be 2x. And both of the dimensions are increased by 4. So we're going to increase that length by 4. We're going to increase that width by 4. So that means that this new length here is going to be 2x plus 4. And that'll be x by 4. Then the area is increased by 88 square meters. So again, what I could do here is take the area of this rectangle, the area of this smaller rectangle, and add 88, and then it'll equal the area of the bigger rectangle. And I think that's what I'm going to do, because again, I'm not going to have to worry about subtracting the negative. So I'm going to take 2x times x plus 88 equals the quantity 2x plus 4 times the quantity x plus 4. And again, we'll multiply this out. So we get 2x squared plus 88 equals 2x squared, and then that's going to be 8x plus 4x is 12x plus 16. So again, what happens to the 2x squareds? They drop out. I can subtract 16 from both sides and get 72 equals 12x, and then divide by 12, x is 6. And again, we want to find the original dimensions. So the original dimensions are going to be 6 meters by 2 times 6, which is 12 meters. Okay, keep going here. We have a rectangular swimming pool. That's an important detail. And it's 3 times as long as it is wide. So this is x, and this is 3x. And it's surrounded by a deck that's 2.5 meters on all sides. So in other words, the distance between here and here, and the distance between here and here is 2.5 meters. 2.5 meters. So it's like I'm taking, this is x, and I'm adding 2.5 and 2.5 to it. So the dimension out here is going to be x plus 5. And then the same thing is going to happen with the length. This is going to be 2.5 meters. This is going to be 2.5 meters. So I'm taking 2.5 and 2.5 plus 3x, and I get 3x plus 5. And then the problem tells me that the area of the deck, okay, so the area of the deck alone is 265, which means, just this area in here is 265. So again, there's a multitude of ways I can do this problem. The old algebra book always wanted us to take the area of the whole thing, subtract the pool, and then it's going to equal the area of the deck. And that's not a bad way to do that problem. You could also take the area of the pool and add the area of the deck, and it's going to equal the area of the whole thing. So the area of the pool is 3x times x, plus the area of the deck is 265, and that's going to equal the area of the whole thing, which is x plus 5 times 3x plus 5. And so then again, we can 3x squared plus 265 equals 3x squared. That's going to be plus 5x plus 15x. It's going to be plus 20x plus 5 times 5, 25. And again, notice that the squared terms drop out. Eventually, we're going to get to problems where those squared terms are not going to drop out. And then we'll solve the quadratic equation. Okay, that's what we're leading up to. But in these problems, those squared terms are going to drop out. I'm going to subtract 25 while I'm doing this. So I'm going to have 240 equals 20x. And I'm going to divide both sides by 20. And x is 12. And again, it wants us to find the dimensions of the pool. So the pool is going to be 12 meters by 3 times 12, 36 meters. It's a pretty nice size pool. Okay. We have a poster that is 25 centimeters taller than it is wide. So again, I like to draw a picture. It's 25 meters taller. So if this is x, this would be x plus 25. It's mounted on a piece of cardboard so that there's a 5 centimeter border on all sides. Oops, that's really crooked. That's not a good looking frame, is it? And so, it's 5 centimeters here, it's 5 centimeters here, which means I'm adding 10 centimeters to this length, and that length is x plus 25. So this new length is x plus 35. And then down here, this is 5 centimeters here, and this is 5 centimeters here. So I'm adding that to x. So this is x plus 10. And then the area of the border is 1350. So again, I could take the area of the frame, x times the quantity, x plus 25. That would be the area of the frame, plus the area of the border. And that's going to equal the area of the whole thing, x plus 35 times the quantity, x plus 10. So this is x squared plus 25x plus 1350 equals x squared plus 10x plus 35x is 45x plus 350. Notice again my x squareds drop out. Then I'm going to go ahead and subtract 25x from both sides. So I'm going to have over here, I'm going to have 1350 equals 20x plus 350. And I'm going to subtract the 350, get 20x equals 1000. Divide both sides by 20. And x equals 50. And so what are the dimensions of the poster? The poster is 50 centimeters by 50 plus 25 is 75 centimeters. Okay. Brick patio is twice as long as it is wide. So here's my brick patio. This is x. This would be 2x. And it is bordered on all sides. I don't think I meant that to be 1/5. I think I meant that to be 1.5 meters wide. So it has a border, and this is 1.5, and this is 1.5, and this is x. So 1.5 plus 1.5 is 3. So that means this is x plus 3. Same thing. This is 1.5. This is 2x. This is 1.5. So 1.5 and 1.5 is 3. Then I'm adding that to 2x. And then it says the dimensions of the patio if the area of the garden is 54. So the garden is what's surrounding the patio. Okay. So again, what I can do is take the area of the patio, add the area of the garden, and it's going to equal the area of the entire thing. Okay, these problems seem to have a theme. So we had 2x squared plus 54 equals 2x squared. That's going to be plus 3x plus 6x is plus 9x plus 9. So again, those 2x squareds drop out. I'm going to subtract 9 from both sides and get 45 equals 9x. Then I'm going to divide both sides by 9. And I get x is 5. And we're supposed to find the dimensions of the patio. The patio is 5 meters by 2 times 5 is 10 meters. Okay. Change up the theme a little bit here. A house has 2 rooms of equal area. That doesn't mean they have to be the same dimensions. Okay. One room is a square, so it is x by x. And the other room is a rectangle that is 4 feet narrower, x minus 4, and 5 feet longer, x plus 5, than the square one. And you think, oh, well, they didn't give me an area. How am I going to subtract or add to get the area? They don't have to, because they told you right at the beginning that a house has 2 rooms of equal area. So that means the area of this room, x squared, equals the area of this room, which is going to be x plus 5 times x minus 4. Or x squared equals x squared minus 4x plus 5x minus 20. The x squareds drop out. I'm going to skirt the 20 to the other side. X equals 20. So what's the area of each room? 400 square feet. Because 20 times 20 is 400, or 25 times 16 is also 400. 400 square feet. And the last one. Small city park consists of a rectangular lawn surrounded on all sides. That's supposed to be square meters, meters squared. Border of flowers, 2.5 meters wide. So we have a small city park of a rectangular yard that's surrounded by a border of flowers that's 2.5 meters on each side. And the entire park is 5 meters longer than it is wide. So if this is x, this is x plus 5. And so this time we're talking about the entire park's dimensions being given instead of the other way around. So when I go to find the length in here, this is 2.5 meters and this is 2.5 meters. So I'm going to get the length from here to here, I'm going to subtract those 5, right? So this is going to be x, and this 2.5 here and 2.5 here. So from here to here is going to be x minus 5. And it says the flower, okay, the flowers are 330, the area of the flowers around there is 330 square meters. So again, I can take that small rectangle, x times the quantity x minus 5, add the area of the flowers, and it's going to equal the area of the big rectangle. And so this is x squared minus 5x plus 330 equals x squared plus 5x. Again, the x squareds drop out. I'm going to add this to both sides, and we get 330 equals 10x. X is 33. And we're supposed to find the area of the lawn. Well, the lawn is 33 meters by 28 meters. And I'm not going to do that in my head. Area then would be 33 times 28. And I get 924 square meters is the area of the, hold on, I think I did that wrong. Small city park consists of a rectangular lawn, that's this, surrounded on all sides by a 330 square meter border. Find the area of the lawn. Yeah, that works. Sorry, I was questioning. Um, but there you go. Okay, and that is that for those.